Hello everybody, this will be our Get Ready video for Chapter 4, and this Get Ready page is located in the front of Chapter 4, so if you choose to look at it in the ebook, that's great. Otherwise, go ahead and follow along with me here, and please take notes in your notebooks. So we look at our quick check questions here. We have a total of 13 questions to talk about today. We are going to start with this first set, and the directions say find the missing value in each figure. And before we actually get into any of the math, if I observe the types of triangles these first four are, I'm wondering if you see something interesting, something they all have in common. So I'll give you a second to take a look at those. The first thing I notice is that these all have a 90-degree angle in them. So they are all right triangles. And then I notice 45 here. This one says 60. So I'm thinking 45, 45, 90. This one is a 30, 60, 90. So the first property we need to recall from geometry is our knowledge of 45, 45, 90s and 30, 60, 90s. So let's see if I can add a page here, move that over a little bit. Alright, so let's take some notes on 45, 45, 90, and then 30, 60, 90 triangles. So let's first draw 45, 45, 90. I'm going to do my best to make sure that this appears equilateral because both of these angles are 45. And our properties state that each leg is equal, so x here and x here, meaning these are equivalent sides, and x root 2 on the hypotenuse. And I will be putting these in yellow boxes. If you have a highlighter, that would be great. Again, I use boxes only because if you choose to print this set of notes off of Google Classroom, if I highlight it, it won't print right. So whatever I highlight or put in a different color, please do the same in your notes. So that covers our 45, 45, 90. Now let's draw our 30, 60, 90. So we still have our right angle, but one of these angles needs to be clearly smaller than the other. So here's my 90, this is my 60, and this is my 30. So we no longer have an equal, a triangle that has two equal sides. These side lengths are not in any way related in terms of their length being equal, but we do have the following relationship. Across from the 30-degree angle is x, across from 90 is 2x, and across from 60 is x root 3. It would be really good if we forgot these properties to put these on flashcards. They definitely will be coming up throughout our trig unit. And we will make a practice of sketching them as well when we are practicing. So now that we have established our properties, let's start using them. Here's number one. Again, the directions are find the missing value in each figure. So I see that I have 90 degrees and 45. Recall that all angles in a triangle add up to 360. So if this is 90 and this is 45, this must also be 45. So I have a 45, 45, 90. I'm going to give you a second to see if you can think about what this missing side will be. If you have a thought, please press pause and give it a try, and then we'll see if we match our answers. Well, my first thought is to use my properties I just talked about. So if I know that this is 45 and this is 45, it means that across from the 45s are my legs. So this is x, which makes this x root 2. And if you can use a different color other than your pencil, that would be great to make what I just put in red stand out. So that means I know that x equals 6. So this is 6, which means this over here is 6 root 2. So notice, this is using x to represent the entire side length. My answer here is 6 root 2. I easily could have written this as a root 2 instead of using x, if that helps you see the property a little more clearly. So again, because if I use if a is 6 here, That means the value of x here is 6 root 2. Whatever works best for you. Number 2. Again, press pause if you kind of have a hang of it or the 30, 60, 90 is coming back to you. Press pause and give it a try. This is 90, this is 60, so I know that's 30. Before I try to analyze any side lengths, I'm going to make a note of my properties. Across from 30 is x. Across from 90 is 2x. And then across from 60 is x root 3. So I know that 15 equals x root 3. I'm looking for this unknown value, which when it comes to the properties would be x. Let's solve. To solve, we need to divide both sides by 3. Excuse me, the square root of 3. The square root of 3 divided by the square root of 3 cancels, that equals 1. And now I have x equals 15 divided by the square root of 3. But we don't like having roots in the denominator. In mathematics, we don't allow that to be our final answer. What is that called to remove this square root out of the denominator? We need to rationalize. So to rationalize, we will multiply both the top, the numerator, and the bottom, the denominator, by the square root of 3. We do this, recall, because I know that the square root of 3 times the square root of 3 will cancel and become 3, but what I multiply the denominator by, I must also multiply the numerator. And in reality, think about what you're actually multiplying by. Square root of 3 divided by the square root of 3 equals 1. So you're not actually changing its numerical value. Let's see what we get. We'll have x equals 15 times the square root of 3 will stay 15 root 3. And then in the denominator, we have square root of 3 times the square root of 3. You have two options. You can either see that as the square root of 9, which becomes 3, or roots cancel, leaving 3 behind. So whichever way works for you. The in-between step, again, would be seeing the denominator as the square root of 9, and the square root of 9 is 3. So whichever way is easiest for you. And then we need to ask ourselves, are we done? Is there something else that I can do? I see here 15 divided by 3, and I can do that. And we get as a final answer, x equals 5 root 3. So that means that this, x equals 5 root 3, the relationship, this side length represents x, so our answer y equals 5 root 3. And we're done with number 2. Number 3, I see I have a 90. These two sides are equal, which locks these values into being 45 and 45. So I have a 45, 45, 90. On your own, please take a second and give it a shot labeling the relationships on each of the three sides. I know that this is x, x, x root 2. So I'm looking for one of the missing legs, and my known information is that x root 2 equals 7. What will I need to do to solve for x? Put a line down our equal sign to keep it all nice and neat. I will need to divide by the square root of 2. Square root of 2 divided by the square root of 2 equals 1. And now I have x equals 7 divided by square root of 2. To remove the radical from the denominator, what do we need to do? I'm hoping the R word, rationalize, comes to our brains. We will multiply the numerator and denominator by the square root of 2. Once again, we can do that because if you think about what this mathematically means, square root of 2 divided by the square root of 2 actually equals 1. So you're not changing the mathematical value of this fraction. Let's do that multiplication. So multiplying straight across, I have 7 root 2. Once again, you have two options. 2 times 2 is 4, so this becomes the square root of 4. And the square root of 4 is 2. So if you're comfortable with saying square root of 2 times the square root of 2 directly is 2, I'm perfectly cool with that. Are we done, or is there something else we can do? Well, I see I have 7 divided by 2, so I can take this one more step and say 3.5 root 2. So x equals 3.5 root 2, which makes this missing value 3.5 root 2. Last one, number 4. Number 4 is interesting because now look at what we know. I know this is 90. I don't know an angle. Now it's an angle that's missing, and I know 2 side lengths. So I'll give you a second to observe this question and see what your thoughts are. The first thing that catches my attention is that in my mind there's a relationship between 6.5 and 13. And I know root 3 is part of my 30, 60, 90 relationship. So let's see if we can make a connection between our 30, 60, 90 and these side lengths. If this is x, let me make it red to match what we've been doing. If this is x root 3, across from x root 3 is 60 degrees. And again, we're all doing this in pencil, so if this doesn't work out, we can erase it. If x is 6.5, that means that 13 is 2x. And across from 2x is 90. That checks out. Which means that this b value must be 30 degrees. And I'm all done. B is 30 degrees. Number 4 was a really interesting question. That was great. Moving on to our next set of questions, the directions say, determine whether each of the following could represent the measures of 3 sides of a triangle. Right, yes or no? And notice there's no qualifications about what type of triangle we're dealing with. So some prior knowledge to bring back of the triangle, inequality, that's supposed to say inequality, theorem. And in shorthand, the triangle inequality theorem states first side plus second side has to be less than the third side. So when you add up 2 sides of a triangle, it has to be less than, and I keep saying less than, I don't know why. We need to have prior knowledge of the triangle inequality theorem. So let's write that down. Triangle inequality theorem. And what the triangle inequality theorem says is that the first side of a triangle plus the second side, so when you add up 2 sides, the sum of these 2 sides has to be greater than the third side. let's put that to the test with numbers 5 and 6. So I'm going to pick any two sides. I'll just happen to pick 4 and 8 to start. So 4 plus 8, is that greater than 12? Let's see, this becomes 12 is greater than 12. That is a no. What if we were to change it? Would it make sense to try 4 plus 12? For the sake of the notes, I'll just write it out real quick. Some of us might be saying already the answer is definitely a no, because that's going to be way too big. But sometimes it's good to check it all out. The only other possibility that we have not added together would be 8 plus 12, but that's even bigger. That would be 20 is greater than 4. Definitely no. So we have exhausted all possibilities. The answer is no. Let's put it to the test for number 6. Do you think number 6 will meet the triangle inequality theorem? Let's see. I'm just going to take the first two sides to start. 12 plus 15 greater than 18. This is 27 greater than 18. Yes. And right there I'm done. As soon as I have one combination that works, I don't have to finish testing anything else. So that's our prior knowledge for figuring out whether or not side lengths are a yes or a no for creating a triangle. Very simple, direct train of thought here, but a very powerful one to keep in mind moving forward as we start working with triangles. Number 7 says, the sides of a triangle have lengths x, x plus 17, and 25. If the length of the longest side is 25, what value of x makes the triangle a right triangle? Notice that it says right triangle. Let's create a right triangle to start. Pictures always help. So I'll make a right triangle. I'm not going to commit anything to what these other angles are like, but this one is definitely a right triangle. And let's talk about these side lengths. X, x plus 17, and 25. We need to recall that for all right triangles, the longest side of a triangle will always be its hypotenuse. So if I'm told that the longest side is 25, that means that 25 automatically comes over here, and then my remaining values are my legs. When I have 3 lengths, for this to be a triangle, it must satisfy the Pythagorean theorem. So we can figure this out. We're going to do x squared plus x plus 17 squared, and this must equal 25 squared. Line down the equal sign, and let's do it. I have x squared plus, recall that this means x plus 17 times x plus 17. Those of us who remember this from last year, I'm just going to put it off to the side. A plus b all squared, which is what this is like, x plus 17 all squared. A squared plus 2ab plus b squared. Those were called perfect not perfect square trinomials, perfect trinomials. I can't remember the 3 letters, I'm sorry. But that is the property, and tomorrow I will remember the 3 letters, I promise. It'll come back to me. But this property holds true. It was discovered or learned when we learned how to complete the square. So using that property, multiplying this out, if you wanted to skip using your arrows, would be a squared, so x squared plus 2ab. 2 times 1 times 17 would be 34x, and then b squared would be 17 squared, which is 289, equals 25 squared, 625. If that shortcut doesn't work for your brain right now, that is okay. Go ahead and use your arrows, multiply out, combine like terms, and you'll get to the same place. Combining like terms at this step, I get 2x squared plus 34x plus 289 equals 625. And to solve here, for any quadratic, we need the right side to be 0. So I will subtract 625 over. That's not what I meant to do. I meant to cross this out. There we go. So I get 2x squared plus 34x. 289 minus 625. If you don't have your calculators out, we will be using it in just a second to guess and check. So go ahead and grab it. Press pause if you need time. 289 minus 625, we get minus 336 equals 0. What can I do from here? I see 2, 34, and 336, so it comes to mind that I can factor out a GCF. So if you weren't sure what to do next, go ahead and factor out a GCF, see what you have left. We get, inside parentheses, x squared plus 17x minus 168 equals 0. And I will leave you for guessing and checking for a second, so press pause. I'm looking for factors of negative 168 that add to 17. Remember, recall from your Algebra 2 knowledge, when A is 1, factors of C that add to B. This 2 will stay outside. And it is factorable, by the way. So persevere, press pause, go find your factors. When I factor, I discover that 24 times 7 is is 168. I have to multiply to a negative 168, which means I get to have one of these as a negative value. And to get to a positive 17, I need the 7 to be negative. So it's going to be x plus 24 and x minus 7. To finish solving for x, we take each factor, set it equal to 0. So I have x plus 24 equals 0, x minus 7 equals 0. We get x equals negative 24. And x equals 7. Coming back to our triangle, we are dealing with side length. Can we have negative side length? The answer is no, so we need to reject the negative answer, which leaves us with x equals 7 as our answer. And let's check it real quick. If x is 7, and here we plug in 7 for x, 17 plus 7 gets us 24. So let's check this answer in the Pythagorean theorem. Is 7 squared plus 24 squared equal to 25 squared? So we get 49. 24 squared is 576. And then 25 squared from what we did before, we know is 625. Let's see, 576 plus 49, drum roll please. We do get 625 equals 625. That's the nice thing about having a picture and a shape to work with. We do have the ability to go back and check. So, this is a reminder that you can go check your answer. Fantastic. Our last set of questions uses prior knowledge from not too long ago. Find the equations of vertical or horizontal asymptotes. So I actually plan on leaving 8 through 13 for you to work on as the rest of your homework solo. But what I will do before I let you go is remind you of that 2.5 prior knowledge. So let's take some notes. Vertical asymptotes come from where? Vertical asymptotes are the real zeros of the denominator. How about horizontal asymptotes? We have 3 cases. If I'm looking at a polynomial of the form f of x equals a sub n x to the n, polynomial in the numerator, and we'll use b sub m x to the m to indicate the polynomial in the denominator. Here are our three cases. Here's a refresher. When the degree of the top is less than the degree of the bottom, that means y equals 0 is our horizontal asymptote. When n equals m, meaning the degrees are equivalent, the horizontal asymptote will be the ratio of the coefficients. And then last but not least, when n is greater than m, that means no horizontal asymptote, except if n equals m plus 1, meaning the degree of the top is exactly one more than the degree of the bottom. So an example would be if I have x to the third divided by x squared relationship, we have a slant asymptote, which would come from long division. Put a little smiley face next to there for long division, yay. And that wraps up our vertical asymptote, horizontal asymptote refresher quick set of notes. So I will leave you to working on 8 through 13, and at the start of class tomorrow I will post those answers on the smartboard so we can check and compare answers. Great job, have a good night, I'll see you tomorrow.